Lesson 5.8, solving exponential equations using logs. So there was a problem that was proposed a few lessons back, right, when we were focusing on exponentials in the beginning of Unit 5, where you had this 2 to the power of x equaling 5. And when we were doing exponents, right, when we solved exponents, let's say this is your problem I gave you, the whole concept was, hey, you need to rewrite the basis so they're the same and then equate the exponents. And in that lesson, I said that there is no way that you can solve for this because there's no way to write 5 as a base of 2. Well, that's where solving exponents using logs comes into play, okay? So we can find this value of x using a logarithm. So if you were to do that, all right, essentially, you'd be taking the log of this side and you'd have to do the log of that side. It's like in math, whenever you do an operation to one side, you have to do it to the other, okay? So let me just rewrite that because that looks messy. So essentially, I'm taking the log of 2 to the x, and whatever operation I do to one side, I have to do to the other. So this would be log 5. Now using my power law, right, I think it was property number 3 in the previous one, so I think it's property number 3 when we learned our basic properties, you can take this exponent down in front so that x comes down in front and it becomes a multiplication. So it is now x multiplying log 2, because there's no more x on that 2 anymore, you brought it down in front, equaling log 5. Well, log 2, like this is just some number, okay? So when you are isolating for this x, because that's the goal, we're solving, right? You have to move that 2 over with the log. It's like trig, right? Where you have to, with that function is part of the number. It moves across. So I divide both sides by log 2. Then I can get rid of that log 2 on that side and leave me with just an x because that's my goal. All right, I'm solving for that. And that is equal to log 5 divided by log 2. And because clearly we weren't able to do it exponential, it's not going to be a nice number. If you put this on your calculator, like you type log 5 divided by log 2, you're going to get approximately, I don't know, something like 2.322. That's why you're not going to get, you can't do this exponential. You need logarithms. So that's saying that when you take 2 and you put it to the power of 2.322, you're going to get 5, all right? But using your rules of exponents, you would never have been able to find that number, okay? So that is a property or a function of logarithms. So logarithms allow you to solve for unknowns in the exponent. I want to highlight something, okay? So let's go back to the beginning. This 2x equaling 5 by rewriting it as a log. So if you were to have this function proposed to you in logarithmic form, it would have been given as x being log 2, 5, right? So go back to a previous lesson if you are confused on how to go from exponent form to logarithm form. But again, the base goes here, the base goes here. The exponent is your answer. And then whatever is equal to the exponent is what's on the inside of the argument, okay? Well, if this was the question that you were asked to solve, right? So if you were asked to solve x equaling log 2 to the 5, your calculator, well, most calculators only have a single log button like that. You'll find that on your calculator. And calculators are programmed to assume base 10. Well, we don't have base 10 in this problem. We have a base 2. So you have to approach this using the change of base formula. Okay? So when the problem is proposing some base b that is not 10, right? So b is not 10. and it's asking you of A. Well, the formula then is saying, okay, well, you can rewrite it as log base 10 now. So now it has a base 10 of A all over log base 10 of B. So now you'd be able to compute it, okay? So if I was to apply it using that same example that we just did, log 2 of 5, well, we don't have a log 2 button, but I can rewrite this as log of 5 divided by log of 2, all right? And now, because I have 10, these are both going to be 10 here, I would actually be able to calculate that. All right, so you can actually see when we rearranged and we took the log of both sides, you essentially got to that same point anyways, right here, right? Log 5 being divided by log 2. So whenever you're asked to solve a logarithm and the base is not 10, you need to use your change of base formula. If your calculator does not have the ability to specify different logarithm base. Okay, so let's get into examples. So for these problems, we're solving for x, so we're solving exponents. And I'm asking you to give me exact and approximate, okay? So that means you're either going to leave your answer like this, that is exact, that is approximated, okay? So if it says exact, you leave it just with logarithms. If it says approximated, put it into decimal. And how many decimals? I don't know, 2. Oh, here we go, 3. Just, yeah. So, but not 1, all right? Try and give me somewhat of an accurate answer. So if we are solving for the exponent, this x here, let me just give myself some room. -2. Well, I'm going to take the logarithm of both sides. So I'm going to take the log of the left side, and then I will have to take the log of the right side. All right, you can't just do it to one side of the problem. Well, if I do that, now I'm able to bring all of the exponent. So both the x and the -2. Okay, so both those come down in front. And so I get x minus 2. Notice my use of brackets, okay? Don't write it as x minus 2 log 5. That's your exponent. Log 5 equaling log 8. And again, you need to move the log 5 over. Right? This is just log 5 is a number. You can't divide by log. Like that means absolutely nothing. So when we are trying to isolate for x here, we need to get rid of that log 5. So getting rid of it means dividing both sides by it. So these cancel, and you're just left with x minus 2 equaling log 8 over log 5. All right, well, if we're doing it exactly, we're going to leave it in that form, that log 8 over log 5. And the last step would just be bringing the 2 over. So that would be x being log 8 over log 5 plus 2. So this right here is your exact answer. Or if you are giving it as an approximate, just try it out for yourself, put it in your calculator. Okay, so x is approximately equal to, well, you're going to type in log 8, and then you're going to, you'll type this, you'll go log 8 divided by log 5, hit the equal sign. All right, okay, I do that because then bedmass isn't an issue. Whatever number you get here, then just add 2 to it and hit equals again. And if you do that, you're going to get approximately 3.292. So try it for yourself, see if you get the same answer, okay? So practice using your calculator because on an assessment, you'll be using your calculator. and you want to make sure you know how to do it. So this is your approximate answer. Okay, beat 3 to the power of x plus 1 equaling 7 to the x. So again, you know that you're going to have to use logarithms here because there is no way to make 3 and 7 the same base and use your rules of exponents. So when you notice that, then apply logarithms to both sides to be able to solve for the unknown. So if I apply a log to both sides, I'm going to go log 3 of x plus the power of x plus 1 equaling log 7 to the x. Well, applying a logarithm allows me to take the exponent and put it down in front, so it becomes multiplication now, and then I can just use order of operations to isolate for it. So if I bring it down in front, it becomes that. And again, just notice my use of brackets, okay? Simple mistake if you get rid of it, like let's say you didn't write a bracket, this is me saying x plus log 3, which is not the same thing as me saying x plus 1 multiplying log 3. So just careful with that, okay? And same thing on the side, bring this x down in front. So we have x log 7. So at this step right here, you could isolate for x by dividing out the log 3, right? The math will end up being a little more complicated. So I would recommend expanding first, okay? So expand at this step. And when I say expand, take this log 3, which log 3 is just a number. So take that number and multiply that 1 and that x. You're expanding into a binomial. So you'll get x log 3 plus log 3 when you expand that bracket. And that is equal to x log 7. And the reason I did that is now I can bring I can separate my log 3 and x log 3. Like where I had one term on this side, I now have 2. And it allows me to bring this log 3 to one side and bring this x log 7 to the other. And that way I get all my x terms on one side and all my non-x terms, so that log 3 on the other side of the problem, okay? So now I can factor out an x from these two terms on the left side here. So that would be x log 3 log 7 when you factor out that x. So I'll write factor. You factor out an x. And on the right side, nothing happens there. Then we are going to divide by log 3 minus log 7. And that way you do that also to this side. So this also then would have to be divided by log 7, log 3 minus log 7. So this bracket and this cancel, and you're just left with x being equal to negative log 3 all over log 3 minus log 7. So that would be your exact answer. Or you can express it as a decimal and just evaluate each one of these logarithms, okay? So practice with your BEDMAS, make sure you, and inputting it into your calculator. And if you do it approximately, check to see that you get roughly 1.297. So that would be the answer you would get if you did it approximately. So try out your calculator, see if you can get that same answer. C. So same as before, you know you're going to have to apply logarithms because you cannot write 4 and 3 as the same base. So in order to be able to solve the unknown in the exponent, we need to log both sides. So 2x minus 1 equaling log 3x plus 2. Now we can take these exponents, put them down in front, so both are binomial. So again, make sure you're using your brackets. So that would be 2x minus 1 log 4 equaling x plus 2 log 3. So same thing you did before. Let's try and get all of our x terms onto one side and anything to do with not an x on the other side. So I'm going to expand in again, right? And you'll start to see a pattern, right, when you do these problems. So I see that I have a binomial with one term being with an x, so I'm going to expand in. So if I expand that log 4 into both terms on my left side, I will end up with 2x log 4 minusing log 4. And then I would expand also on the right-hand side. I'm going to take that log 3 and multiply that x. So that's x log 3. And I also need to multiply that 2. So that's plus 2 log 3. Again, this step allowed me to get to the point where I can take all my x's on one side and anything that doesn't have an x, so doesn't have an x, and keep it on the other side. So I will bring this term over here, and I will bring this term to that side. So I will get 2x log 4. Once I bring then that x log 3 over, I get negative x log 3 equals, well, that 2 log 3 stays there, right? So that is that, and that, just so you can keep track of where things are going. And then I had the plus log 4. Okay, I'll just pause there for a second just so you can see where I brought things over. And now at this step, I am going to factor. I'm going to factor out the x. So if I factor out an x, I will get x being 2 multiplying, x multiplying 2 log 4 minus log 3. And then nothing happens on this side at this step. Log 4. Lastly, I just want to isolate that x. So I need to divide out the 2 log 4 minus log 3. And then if I do that on that side, I have to do it on this side. So 2 log 4 minus log 3. So that cancels with that. And you're left with x being equal to 2 log 3 plus log 4 all over 2 log 4 minus log 3. That is the exact answer. And then if you were to approximate it, or what is the approximate answer? So try it out, plug it into your calculator, right? And check to see if you get the same thing I do, where it is x being approximately 2.141. So that's your approximate answer. So short lesson for today, all right? Just a big recap. We are solving for exponents, and when you are solving for exponents where you cannot equate the bases and use your exponent rules that we did in the beginning of Unit 5, you need to use logarithms. All right, I will see you in class.